Hello and welcome back to TechVibes. For this video, I have created a Wi-Fi network scenario and I am going to show you how easily I could triple the effective Wi-Fi range with only 3 simple changes. And no, I did not use any range extender, repeater, or even a mesh system. All I used was a state of total awareness. By achieving true awareness, you can be prepared for any network danger that may befall you. What I mean by that is I became fully aware of 3 key pieces of information. First, the best way to install and place a wireless router. Second, understanding the wireless environment and setting up the Wi-Fi network accordingly for optimal performance. Third, leveraging some professional Wi-Fi features that can help to extend the Wi-Fi range. So I made some improvements in those 3 areas, which could actually triple the Wi-Fi range of that wireless router. Before we start, I just need to mention that at the moment, the Wi-Fi range of this router does not cover the entire house. There are many dead zones inside. The signal strength in the garage is so weak that it is not even possible to connect, let alone in the backyard where there is no signal at all. If I can provide coverage for the entire house, garage, and backyard, I think we can all agree that I have more or less tripled the Wi-Fi range, or at least come close to that. That would be absolutely great. First, let us focus on the installation. Currently, the router is installed on the ground behind the TV where there are other electronic devices as well. For example, there is the TV itself, a PlayStation, speakers, a whole bunch of wires, and more. There are many issues here. First off, the router should not be on the ground. It should be elevated to about the height where you usually keep your wireless devices, like a laptop on a desk. This is the best height because the omnidirectional antennas of routers broadcast signals horizontally in all directions, so it is usually strongest for devices at the same level as the router. Also, it is best not to place it in a confined space or near other electronics. These things can interfere with the Wi-Fi, block the signal, and significantly degrade the range. Because of the nature of omnidirectional antennas, it is best to keep the router in the center of the house and not close to one side. Otherwise, you will be wasting your Wi-Fi signals and not taking advantage of nearly half of its potential. Finally, in a single-story house, it is usually best to keep the antennas in a vertical position. Again, this is because omnidirectional antennas broadcast signals horizontally around the antennas, in a shape somewhat like a donut. If I keep the antenna horizontal, the bulk of the signal would just go to the roof. After correcting these basic installation guidelines, which should not have happened in the first place, there is already a huge difference in the range. Using a Wi-Fi analyzer, I can see that the garage is now covered by both the 2.4 GHz and 5 GHz bands. The 2.4 GHz signal is great, and the 5 GHz signal is good. So this simple correction alone pretty much doubled the effective coverage area in the house. You might ask who would install a wireless router in that bad situation. Well, I personally know people who actually have done that at some point in their life. Now let us move on to the next step, which is setting up Wi-Fi based on the environment. This could be a broad topic, and I have discussed different aspects of it on TechVibes before. For example, we know that the 2.4 GHz band has a greater range compared to 5 GHz and 6 GHz bands, but it offers lower speeds. So it might be a good idea to set up a 2.4 GHz network specifically for devices that are likely farther from the router and do not necessarily need fast connections, like smart home devices. Then you can reserve the 5 GHz and 6 GHz networks for devices like laptops and smartphones that need faster speeds and are typically used closer to the router, such as in the living room or bedrooms. Although that is very important and definitely something we should take into account, that is not the primary focus of this video. In this video, I want to talk about tricks we can use to reduce interference as much as possible. Wi-Fi interference can not only lower speed but also heavily reduce the range of your Wi-Fi network. Since Wi-Fi uses radio waves, anything that interferes with these signals can weaken your Wi-Fi and reduce its range. One way to reduce interference is by choosing non-overlapping channels. For example, the 2.4 GHz band has only 3 non-overlapping channels, which are channels 1, 6, and 11. If one neighbor is using channel 1 and another neighbor is on channel 11, you can safely use channel 6, and there will be no interference. All 3 networks can coexist with no issues. However, here is the tricky part. When I set up Wi-Fi for each band, not only can I choose the channel, but I can also choose the channel width, meaning how wide the channel actually is. Each 2.4 GHz Wi-Fi channel has a standard channel width of 20 MHz, but the space between each channel is only 5 MHz. That is why when I choose channel 6 and use the standard 20 MHz channel width, it covers the area from channel 4 to channel 8, and it does not interfere with channels 1 or 11. However, if I select a 40 MHz channel width, it now covers channels 2 through 10. This might seem good because it provides twice the bandwidth, potentially doubling the speed. But here's the major catch: it also causes interference with pretty much every other channel that my neighbors might choose. A more or less same principle applies to the 5 GHz band, but the channels can be much wider, for example up to 160 MHz in Wi-Fi 6, and there are even more non-overlapping channels available. So long story short, although 40 MHz and 160 MHz channels theoretically offer faster speeds, sticking with smaller channel widths is often better. This is especially true in crowded environments like apartment buildings. This choice provides a cleaner and more stable connection, allowing your Wi-Fi signals to reach further and maintain better performance even when there are other wireless networks nearby. Think of it this way: in a traffic jam, if you have a supercar, it does not really matter how theoretically fast it can go because it will just get stuck. But if you have a scooter or even a bicycle, it can go through the traffic much easier and most likely much faster. The 20 MHz channel acts exactly like a scooter in a traffic jam. Of course, on an empty freeway, the supercar is faster. But in the reality of the Wi-Fi world, we are most likely in a traffic jam, so the scooter is much more practical. My original settings were 40 MHz for the 2.4 GHz band and 160 MHz for the 5 GHz band. After adjusting the channel width to 20 MHz for the 2.4 GHz and 80 MHz for the 5 GHz, I noticed a huge signal strength improvement. I saw a 5 dBm boost for the 2.4 GHz band in the garage and a 6 dBm boost for the 5 GHz band. As a result, the 2.4 GHz band now has strong coverage all the way in the backyard, while the 5 GHz band is also quite decent. Finally, let us talk about using some advanced features like beamforming. Beamforming can extend Wi-Fi range by focusing the wireless signal directly toward connected devices rather than broadcasting it in all directions blindly. This is achieved through the antennas of the router, which work together to send more concentrated beams of data directly to the devices. By directing the signal exactly where it is needed most, beamforming enhances both the range and strength of the connection. This is especially helpful at the edges of the network, leading to better performance in areas that would otherwise have weaker coverage. I have made sure that in the professional wireless settings, both universal beamforming and explicit beamforming are enabled. Universal beamforming, also known as implicit beamforming, works with any Wi-Fi device, even older ones. It does this by making educated guesses about the location of the device to improve the signal. However, it lacks direct feedback from the client device, making it slightly less precise. Explicit beamforming, on the other hand, requires both the router and the client device to support the technology. It allows the router to receive feedback from the client, enabling much more accurate and efficient signal focusing. By enabling both types of beamforming, the router can maximize its capabilities to deliver a stronger and more reliable Wi-Fi signal throughout your entire home. After making these final adjustments, there is now a consistently good signal in the backyard for both bands. I think it is safe to say that after making these simple changes, my Wi-Fi range has completely tripled. This is awesome and just goes to show how important it is to consider these simple yet crucial points, which are all part of a good network design. Every time I set up a new Wi-Fi network, maybe I do not necessarily need an expensive mesh system or a range extender. Maybe I just need to design or redesign my Wi-Fi network correctly based on the environment and my requirements. Thank you very much for watching this video on TechVibes. If you enjoyed these network tips and found them helpful, please drop a like on the video. Be sure to subscribe to the channel so you do not miss out on any future tech guides. Finally, leave a comment down below letting me know how your own Wi-Fi setup is running right now.